This video is to review parent graph transformations. I've written out some key things here that you should pay attention to. You really need to know your parent graph functions, and I reviewed that in one of the other videos. And what I mean by that is you need to recognize the shapes, and you also need to know their equations. I'm using the quadratic equation here to illustrate the patterns, but this pattern works for all of the different parent graphs. You have a number out front, usually a constant, and that can either be positive or negative. And that's going to tell you whether the graph faces up or down. So if it's positive, it faces up, and if it's negative, it faces down. You can have a number inside with the x, and if that number is positive, it's going to take you a shift to the left, which is opposite of what we think. Okay, remember it's the opposite way inside with the x. And if it's negative, then it's going to be a shift to the right. And then the value on the outside, if it's positive, it moves up, and if it's negative, it moves down. So that's just a quick review of what those numbers do. Now, a key with your transformations is that you have a graphing calculator for the SOL. So yes, you should know these rules and be really comfortable with them, but always use your calculator as a backup tool to double check your answers. So the first example we're going to look at here is which is most likely the equation of the graph above. So this is a quadratic. The first thing I always look at is my left or right. So I see that it normally starts off intersecting at the origin. So that's something that you should know. Where does it normally start? And I see that it's been shifted to the left, or excuse me, to the right, 2 units. So I'm going this way 2 units. So I know that's going to be inside with the x, and it's going to be a negative. So I'm automatically ruling out these 2 answer choices, because I know it has to be x minus 2, because I'm shifting to the right 2 units. And then I also shifted down 1 unit, so that means it has to be minus 1 at the end, so that's answer choice D. Now, like I said, I would also graph this on my graphing calculator and match that up with this and make sure it looked exactly the same, because I have that tool, so why not take advantage of it? And the last example that we're going to take a look at here, name the equation of the graph shown. The parent function for this is a cubic. Now they might throw in different parent functions here just to throw you off, but we can see that they are all the same here, so we don't need to know that. What you should recognize here is that the original goes through the origin, just like with the quadratic, so we need to recognize the shift here. The shift is 1, 2, 3, 4 units to the right. So we moved this way 4 units, but we didn't move up or down. So I know it can't be either of these because it wouldn't be outside. My shift is going to be inside with the x because I'm moving to the right. And because I moved to the right, it's going to be minus 4, not plus 4, because I know it's opposite of what I normally pick. And again, just to double check on this one, I would graph this on my calculator and make sure it looked exactly like this. If you have more questions on transformations, please see your math teacher.